Let's talk about heat. Heat is very important in chemistry, especially combustion reactions liberate a lot of heat. That heat can be used to provide mechanical work for us, provide electricity, provides work for an internal combustion engine, makes our vehicles accelerate. And then biochemical reactions, the reactions of life, are exothermic, meaning they liberate heat, and that's how our bodies derive the energy to move our muscles. Now we let the symbol Q represent heat in chemistry and physics, and Q, the heat transferred during a process, is proportional to the temperature change of the substance. If we add a little bit of heat, we raise the temperature a little. If we add a lot of heat, the temperature change is larger. So we can express Q with an equal sign if we use a proportionality constant, which we'll call C, and C is called the heat capacity of the substance. The temperature change will depend upon the amount of the substance present. A small amount of heat is only required to raise a small amount of substance a certain temperature change, but larger heat is required to change a larger amount of substance for its temperature. So we write Q is equal to the amount. We use M for mass, the amount of the substance. We'll use C sub S for specific heat. And the difference between heat capacity and specific heat are just the units. One is in units per mole and the other is per gram. Specific heat is per gram. And then we have multiplied the temperature change. The specific heat is a constant for each substance, and we can look that up in a table. It's a constant to a first approximation. And say we have 100 grams of water, and we want to raise the temperature from 25 degrees centigrade to a temperature final of 50 degrees centigrade. We want to know how much heat is required. So Q, the heat required, is equal to the mass of water, specific heat of water, times the temperature change. So we look up in a table the specific heat of water, and we find that the specific heat of water is equal to 4.2 joules per gram times degrees centigrade. So the heat required is equal to 100 grams of water times the specific heat times the temperature change. 50 degrees centigrade minus 25 degrees centigrade, giving a Q of 10,500 joules, or 10.5 kilojoules of heat transferred. So notice that the specific heat has units of joules per gram, and so the mass of the substance will be in grams, and it also has units of per degree centigrade, and so the temperature change, delta T, will be given in degrees centigrade, and delta T is just an abbreviated way of writing the final temperature minus the initial temperature.